Diese Konferenz wird nun aufgezeichnet.
And yeah, hello to all the people who are only watching this session by video from YouTube channel IBExpertise or on www.ibexpert.com/get-together. You will also get the download address for the files from last week there, and you can also do some watch some recordings from the last videos. If you know also the German language, you're also welcome to attend the German videos. Yeah, let's talk a little bit about the basic motivation between what we are talking about. We have very often customers who are working with a lot of blob data in their database, and a lot of people always think that blob data does not belong into the database. It's definitely not my personal point of view, because I really like to have blob data in my database, because when I have, for example, a PDF file or an image file or whatever in my database, it is guaranteed that this file is under transaction control. It cannot be deleted when the trigger does not allow that. It cannot be updated when the trigger does not allow that. And it could be that you have a much more reliable source of database of files in your database rather than having that in the file system. And a lot of people know perhaps also the problem when you are searching on your local disk for a specific file. It takes a lot of time. You sometimes have to wait for not only minutes, but especially in the times before the SSD technologies, it took around more than 10 to 20 minutes if you are searching for a simple file. And if you still need to have the same functionality, I will close my window, otherwise you will listen to the local church. I think it was not loud, but it's a little bit annoying. If you, for example, work with a local file database files with a local file system with a lot of files, and you made for perhaps as an error reason, by error you made a local directory with 1 million files or something like that in a Windows NTFS file system, you are already in a little bit trouble. Because it's almost unusable to use that file system any longer. And for example, if you have 1 million records inside a database file, it is much more easier to handle that. Also doing some containing search or whatever you need on that database, you have a lot of advantages to do so. Let's start with a new database. We are creating a new database. We are creating that new database on the local system. We are working with a database file, not there, but here, dbfiles.fdb, for example. And we say client library file is the client library file that we always recommend. If you do not have already a defined client library file, use the one that you really can use, because most important is for IBExpert, you need a 32-bit client library file, and it should be a version that is, for example, also usable with your Firebird server. We are working at the moment with a Firebird 3 on this local machine. So you can see that directly when you are looking here. And if the process name is firebird.exe, you are definitely working with Firebird 3. If it's FB server or FBEnet server, you are working with Firebird 2.5 or older. Yeah, let's go back to the client library file. We have here a client library also available for Firebird 3. And good old combination, sysdba, master key. If you have not already installed Firebird, one of the first session videos is still available online, and they will remain online, where you can, for example, also find out some tips and tricks how to install a Firebird server really easy and really in a good way. Depending on the language area where you're working on, it's always a good idea to have a character set in use at the moment, because of some of the American people are also attending, and they do only have 26 characters. They do not need a character set problem. But in a lot of other countries, South America and so on, and I know some of you are from South America, we often work with ISO character sets, ISO or the good old UTF-8 character set. But I want to work in that example today with character set none, just because I want to avoid problems that we do not want to have. Okay, I pressed on OK, and the database registration, I will have to say which version we want to use, and depending on the version that we are using here, the new database is automatically registered, and when I click on register, we have this database available. Let's start with a new table. Create table files. And I always recommend when you're writing any SQL statement and naming objects, and they could be something in the future or in the past, that could be a system keyword, it's always recommended not to use that word. For example, files is at the moment no internal keyword, but we rename it. For example, like something with an X before. Just as a proposal, always use other words than the system words, because sometimes you might have a problem in the future when you are using a SQL statement in a Firebird 4 version, and in Firebird 4 it could be a SQL statement that in Firebird 4 includes a system keyword as a character column name or as a table name. And it is still possible, but it could be a kind of an incompatibility between the versions. And so simply use a prefix in front of all your tables when you are using such a keyword, or could be a keyword. But for example, because why I recommend that, we had the German Telecom project very long years ago, and we were coming from Interbase 4 to Interbase 5, and they had in that time a table name which was called admin. And the problem was, in Interbase 4 admin was no keyword. In Interbase 5 it was a keyword, and in Interbase 5 they did not introduce the quoted names, and so we really were in trouble with that situation, because select asterisk from admin did not work, because it gave us a problem after a backup and restore, and everything drop table admin also did not work. We had no access to that table because the quoted names for such system word objects was introduced in Interbase 6, and we were a little bit in trouble. And the only chance that we had, because they were already in work with that database in a production system, was using a hex editor and manipulate the RDB dollar relations, RDB dollar relation fields, and all these tables by hand. That worked, but that was no real good idea. So always try to use words that are not typical English keywords. One of the most often used keywords that are often used by people who do not have such amount of experience in Firebird is also very often position as a column name or as a table name. And it's a very stupid idea to use a position as a column name. Make a short version of that, POS or something like that. That's okay, but not the word position completely. It will give you some disadvantages in later environments. Okay, let's do some create table files. We do a ID big int, not null primary key, as always in my database systems. Not null, I should write that also and not only ignore that. And I do a fn, like a file name, which is a varchar. 255 or something like that. And what we are doing next is data or something like that. And you see already here in IBExpert, data is also already a system word. So also here use please xdata or something like that. We take it as a blob. And blob subtype, we do not only want to have text files stored in that database, in that table. We want to have the possibility to store also PDF files, images, and everything else. So we are using just blob without any specific subtype. In that case, it will always take the subtype 0, which is the subtype binary. So you can directly also write subtype binary if you want. We press F9 and we have now already the table filled. And let's take some data into that table. We already did some things like in one of the older videos that we already were working on when we were importing some data using IBE block scripts and so on. If you need that, just have a look at these things. It could be a very interesting way, but I will show you also a part of a job that I did for a customer a few years ago, and it could be also perhaps interesting for you. We have here some files in the get-together subdirectory with .dat files and some other files and so on. And what we want to have is at the moment really simple. We just want to have some data in our database. So we just want to have all these files in that subdirectories in our database to have some basic amount of records already filled. And it's not such a hard job to do so. And let me show you that. I will start in SQL editor. I will go in IBEC get files. And IBEC get files is, for example, the function to understand, to detect the files in a specific directory of a specific extension and so on. And anytime when you're, for example, writing a function name here, it's not a big problem to have this function name written already. You can directly use the code completion for that. You see already that. And whenever you are on that function name, just press F1 and you will see the individual website where you can get the information how it is usable. And let me show you the inserting file data into a database. Let me show you that part. So that part we will take as a template. The upper part is helpful when you directly want to use the full example. But we do not want to have the full example. We just want to have that part working here. And what we also want to have, we want to have a generator. And I always call my generators ID because I'm too lazy to write more characters. I could also use only one character, but that's not a good idea, I was told. But it's a similar thing like using two characters. So searching for files, I do not say script files, I simply say files. And I just want to have the drive C and the subdirectory GT. And I want to have all files. So I have the full mask. Recursive search, it should also detect all files from the subdirectories, and the full name is wanted, so including the path. If it has found at least one file, it should do the following. This one is simply for counting up the individual position in the file list, as you can see here. So it's an array where all the file names are in. I take the file name from file list position E. This one is not really needed. This one is not really needed. This one is done. And I take this here, for example, I call this xdata. And I say here, adding file name. and I remove that part because I want to have that table first connected to the generator. I almost forgot that. So I want to say the generator I just created, use existing generator and create a trigger for that. And always have in mind, if you are coming from, for example, a Fiber 2.5 and you are working now with Fiber 3, generators also have user rights. You have to grant generators. When you're doing a backup and restore, or you create generators inside IBExpert generator, as you can see here on the double click, you also have to give him access rights. So it's not automatically public as in Fiber 2.5. You should have that in mind also. And as always, we are simply doing the lazy stuff. We are simply drag and drop the X files table from that directory to this directory. We simply have here the information insert into, and we simply remove, take it on one line only. We remove the ID because the ID is set automatically because of the generator. The FN, the file name, is in that variable. So we change that from that variable. And this one here is, for example, now used for getting the data from that file name. So what is physically done inside the database operation? We can do a commit at the end. We do not have to do it at the beginning. So let's do here the commit. What is done when we are using load from file? It is stored inside a memory variable inside our database, and we can use that file content and put it into that SQL statement directly without any additional importance. So let's save the file. And save the file. We save it in a different directory just to have it somewhere else. GT2, I call it. And I simply say import, and I just say here, this one, the IBC progress, is just for giving us here a hint what is the script is currently working on. So it's a very easy thing. And you just have seen already that everything was already executed. Let's have a look at the X files table. Let's go to the data, and we see here a lot of files already in the table. And it's a really easy way to do that. So we just here have, for example, the content of that file. When we go back to, for example, a different, to this here, for example, this is a PDF file. This is the original PDF content, and when we simply say as PDF, we say, okay, that's the Firebird Quick Start Guide. Okay, so now we already have some data in our database, and having some data in our database, for example, gives us the possibility to do some operations on that. We can do select, we can do containing select statements when we, for example, want to have some result sets based on the data inside that table. But what I want to show you now is really simple. The basic idea behind that current situation is to understand the current database has approximately 26 megabytes of space. That's really small, so that's almost exactly what we have in that subdirectory. We have 22 megabytes of files in that subdirectory. And when you consider to have a really big file system, it could be an option for you, for example, to do the following. If you want to see, for example, database files which have the same content. It could be, I do not know at the moment if we have several files multiple times inside our database system already. You can do something like the following. Select FN, and there is a so-called hash operator for the X data from X files. And the hash is really simple, a function to get a kind of a checksum on that specific blob content. And when you have a look here, for example, you see here, for example, already the 2.pdf and the 3.pdf have exactly the same hash. So one of the things that we can, for example, at the moment have a look at, and you will see here, this one is also exactly the same. We could, for example, simply do a analysis on the database, on the files stored in the database, and we could do some implementation that files which are already in the database file, because we know already the existing hash, will not be stored once again. Let's have a look at a way how to find that we see the multiple hashes. We do, for example, the hash and count from X files group by 1, 2. So now we have here a list of table data, and when we have a look here, we should have a that was a stupid idea. We just have to do the hash X data, and then we see, for example, that some of the files are here available. For example, with the maximum content is this file with the hash. It's a simple empty file. It is already here, and this one is already also here. And one of the things that you can do with the hash file is detecting the content of the hash file if it's really different to the content of the hash file that you are working in another database. You do not have to transmit the full content of the database of the blob. And when you have a look at tools, table data comparer, for example, you also have the possibilities to compare table 1, database 1, database 2, and each of the tables which have here, for example, a different content can be checked by yourself. And you have one of the options here, for example, also that you can say, okay, use a hash function to compare blobs if possible. If you want to compare, for example, two databases, and the two databases have a large amount of blob data and big blob data, when you do not activate that, it will download the blob content from both databases and will compare them locally. If you're using the hash function, it will only check out the hash on both databases and then compare the hash. And when they are not different hashes, it will go much faster on these databases, which also contain some blobs. So let's have a look at the next step, what we are working on. So we have already a lot of files in that database. We have, for example, the possibility to store. Also, if you like, you can also store the hash content inside the database file, so you do not have to recalculate that every time. But one of the things that a customer reported to me when he saw this example, which is a very simple example, as you can imagine, this import example, he decided to let this script run on his NAS system, and he downloaded everything from his NAS system together with the hash into his database. So he simply was doing a hash inside the database, but did not store every blob content in his database file. In the first run he made that, he stored simply the hash of the blob data, but he did not store that in the blob data. That's also a possible way. And the funny thing was, he was detecting that on his NAS system, he had approximately Adobe Acrobat installer was approximately 135 times on different directories, but all were the same version. And he was replacing them also by a technology and the file system, which is a link to a different file, which is also a possibility inside any Windows version. And he replaced all these real files by a link to one of these files. And he detected that the NAS system had approximately 10 terabytes of files before he was doing that. And he were going down to less than 2 terabytes after simply removing duplicates. And removing duplicates is also one of the things that you can do with that. But we want to have a basic overview what you can do with blobs in a different way. Let me show you how we do that. Let's have a look, for example, at this table. When we have a look at this table, we see here, for example, the individual file names. We see here the primary key column, reset field order. Now we see it in the correct order. And we have here the data inside our database. And when we want to see very simple operations, select fn char length, fn char length x data from x files. You also have the possibility to see the length of the content of the individual files without really needing to export them. For example, the customer.html file is the biggest one that we have here. We have some other files here, but that's one of the bigger ones. So if you have a look at the original file, which is somewhere here, the customer.html file, which is this one, 7376, and this one here is approximately 75, which is the counting of bytes. I do not have to explain that to you. But we want to have, for example, also the possibility later to have that current database giving this database a possibility to still store the metadata, and I currently simply call this metadata, the file name and the original part, in one database, but the real data should not be required to be in that local database. So how to do that? We are starting a copy of that file. We clone registration info, and we simply call this, for example, archive. That's dbfiles-archive.ftb and dbfiles-archive.ftb. Recreate database. We have an empty database, and now we have a really empty database. So the easiest way, what we want to have the data in the second database, so the X data field should be in the first or in the second database, and it should be automatically operated in the first database. That we want to have the possibility that the data comes from the second database or from the first database, and we will want to have that transparent in the local database. So how to do that? We take the DDL statement from the X files table, and we simply say here, we just copy that part that is interesting for us, and we open dbfiles-archive.ftb, we copy that. And what we do not want to do now is really simple. We do not want to have the file name in both in databases. We just want to export the individual blob data, but not the metadata. Metadata, for example, in that case, what is the file name? Where does the file name exist? Is it a PDF file? Is it a HTML file or whatever? The metadata of files should be in my production database, but the content of blob can be, for example, in the second database. So what I do simply now, I remove the FN here, and we simply do the execution, and now we have our own table here in that database. So let's do now try to move the data from this database to the second database using, for example, a very simple sort procedure. We are creating a new sort procedure, and we simply say X files arc, we call it, and we simply do the following. For select ID and the we only need the ID. Now we take the blob data also already X data from X files where X data is not null into, and we now define two variables. And variable declaration, you can do it by hand, but who wants that? We simply want to have the drag and drop again and declare variable, type of column, and so on. So we have here all three variables, and we can directly say here into ID X data do begin end. And what we simply want to do in the archive operation, so we want to move the files from the current production database, for example, to our archive database, is extremely simple. We simply say here execute statement, almost the right characters, statement. That looks better. So always when it gets bold, it's written correctly. Execute statement. What do we want to have? We want to have the insert or update on the second database file for the X files table, but the X file table has only X data and ID as columns. We simply use two brackets here, and we start here with a string. And what we want to have is really also again done here by a drag and drop operation, but from the wrong database. In that case, I have to use it from this database, because in that case, I get a update or insert statement already almost perfectly prepared for what I need. So we just want to have here the update or insert statement. And since we know that the X files on the second database will have its primary key already on the ID column, we do not have to use the matching clause, because matching is only needed when we do not work with the primary key in that operation. And the interesting thing is really easy. Execute statement allows us to work with parameters, and these variables for the parameters are connected to the execute statement in the second operation. And we simply say ID equals column equals ID and X data X data. Or if you have multiple operations to be done, simply try again, drag and drop. And you can simply go here on name parameter list, and you get a full list of all the columns for the individual table automatically. So you do not have the problem when you're working with tables that might have, for example, 50 or 100 columns, that you have to write them all correctly. What is extremely important to understand is, if I rename, for example, X data here to a different value, to a different name, I do not have to change it here, because that one is part of the select statement. That needs to be in the same way. Here it's a variable, it's a reference to the variable. And here on the right side, that's also the reference to the variable. That's important to know. The left side is a reference to the variable inside my statement. That's really important. We do not have to rename them. because we can use the same name for everybody. That's no technical problem in Firebird. But you always have to know that the left part is always a part here inside the SQL statement. The right part is always a part inside the context of the current operation. So it can be done from inside a trigger, it can be done from inside a stored procedure, or also inside a function, and every operation like this can do that. So we want to do the execute statement, but we do not want to do it in our local database because we want to do it on a external database, and the statement for that is really simple: on external. And in external, we now need the database connection string. I simply copy it from here. Or this is the original alias name. It could be different. If you click here, you will have automatically the correct connection string inside your clipboard. And we can simply put it here as user sysdba as and password master key. And this is already on the first point of view already a really stupid way to do so. Just one of the things when you're already working with Fiber 3, perhaps do it a little bit different, because this one, when you are writing this one, that is already part of the metadata, and every metadata export will directly show you exactly what is here inside. A very simple way to do it differently would be the following. We create a new function, at least for the password. I call it pvd, returns varchar 20, for example. And I simply say return master key. So that's really simple, a simple way to write a function. And that could be done from select from any table, or a very different way, or encrypted string, decrypted string, whatever you're doing in that DDL metadata here. And you can here now use, for example, instead of the constant master key, the pvd function, like you know that, for example, also from the Delphi world. So when we are doing that and compile that, it works directly. And what happens when we did that successfully? It makes sense to do an update locally, update xfiles, set xfiles dot xdata equals null, where xfiles dot id equals id. And this one here now is not done on external, it's done on the local file, on the local database file. So let's compile that and simply let that run. Here can you already see 41 records were already updated in xfiles. I commit that. And when we now do a disconnect from both databases, just a disconnect to be sure that everything is reloaded from cache, and we go to the xfiles table, in our production database, we see here no single content of the xfile xdata column, but we see on the archive database exactly that content. So we simply have here everything inside our archive database. And the good thing is, for example, at the moment when we want to access this data, we will have some functions that we are using later for accessing the data. We can also do a dearchivate functionality inside our archive database also. For example, I simply take here this one, and I can also do the DDL with all the individual statements. But the first thing I need to have also in the second database is a PVD function. And what we can do here, for example, also a lot of people do not know inside IBExpert, we can say here in the database registration info, we can simply say that here in the, where was it? The comparative DB, very much below, should be always the second one. And when we do now the comparative DB for the second one, that's not needed, but just to show you the functionality that we want to have the comparative DB to that one. And now what we are doing in the next step is really easy. We first want to have the function PVD to be copied to the next database, and we have a functionality here, copy object, and it will it should have already showed me here the DB archives database. For whatever reason it did not do that, but it will create that also now. Try to drop the function if that exists already. Let's start that. Function was transferred. We have here the function now already. And when we now want to, for example, go to the procedure, the procedure should not be copied because we do not want to have the original procedure. We want to have the procedure inside our second database to be a DArch procedure. And the DArch procedure is really simple. We just want to have here the update or insert into X files, X data. We only want to get the X data informations to be transmitted to the second database. And we want to have the target now to be the DB files database using the same functionality. And in our archive database, when the full record is no longer needed, we simply want to have the complete record to be deleted. Delete from X files, where xfiles.id equals that. That's really no good idea, because IBExpert tells us, or Firebird tells us, that the column fn does not exist in the table and view, but we do not need that. So it's no problem to simply drop that. And I should definitely write X files in the correct word. So let's compile that. And what we are doing next, we are simply testing that table operation. And when we did that, we see already 41 records were deleted in that files. We see here in the local table, no more data is left. And when we have a look back at the original database file, we see here every record again in our database. If you want to see, for example, the content, the size of such a database inside your database, how much space is used here inside your database, and you go to database statistics. In database statistics, you will get the basic information about all the records inside your database, but except blobs. You will get here some basic information, how many blob pages are used, but that started with Firebird 3 in the statistics, and one of the latest versions where you can have a basic overview about that. But the most important thing, for example, if you just want to see, for example, some statistics, just have a click on blobs. And on whatever reason, I get an error message here. I have to look it up. I do not know why this happens. Just try it with your own database. You should have a statistics on the blobs, which give you a very good overview, which one is the biggest table with all the biggest data inside. The newer Firebird versions often allow you to have here some more information, and you also find here some information about the pages and so on, how many pages are used for the blob. But in Firebird 2.5, you do not have these informations in the statistics. And if you need to, for example, to understand why your database is so big, sometimes it's really interesting to just have a click on Firebird 2.5 databases with blobs. Should also work with Firebird 3, but don't know where the current error comes from, but should be not such a big problem at the moment. So we have the data, we can put the data between the two database files. And the interesting thing at the moment is, for example, also that we can do, for example, access the data here from the table, and we have here the X data in the table or perhaps outside the local table. At the moment, we need a way how to operate there. And what we can do inside IBExpert and also inside Firebird is a very simple way. We can, for example, here click on Create View. And we simply do a Create View VWX files, we call it. And we leave it simply as a default we see here at the moment. We compile it. And the view allows us currently, when we have a look at that view, to see the original data exactly as they are in the table. That's no big deal at the moment. But the very interesting thing could be in the next way. We can, for example, use a procedure or use a function for that. I would simply start with a procedure to show you that. It's not a big problem to change the function, change a procedure code to a function code, or simply use it in exactly the same way. The new procedure that we are creating is now simply called get X data. And we want to have a parameter. We want to have the X data for an ID parameter, which is a big int. And it should return blob and X data blob. So what does it simply mean? Anytime when we want to have access to the content of any blob, we do not directly go to the individual table. We directly open the X data procedure, and the X data procedure can now perhaps make it possible for you to understand, okay, is it data that is currently in the X files table in my local production database, or is it already archived in the other database? That's not really a big deal for this procedure. The basic idea is extremely simple. Select X data from X files where ID equals ID into X data. If X data is null, then execute statement and now we have almost exactly the same construction. The into operator goes outside, and here we have to give them the parameter ID equals ID, and the same technology on external, and now we go to the same construction as we have done here already. As user this DBA password into X data. And if it has already found the data locally or not, it's no big deal. If it does not find it locally already, it will have a look at the archive database. And which are the different archive databases could be, for example, now done or taken from a archive database table where you have several connection strings for the archive databases that you have already created. And it could, for example, also do that here for not only one step. It could be done, for example, for an archive database 2019, for an archive database 2018, 2017, or whatever. And you can, for example, do a kind of a yearly database automatically. And we will do some small changes to have, for example, the files archive database already in read-only mode and activate a new secondary files database. That's a really easy extension to that current model that I showed you. So get the X data is now extremely simple. We can, for example, do here a very basic operation. Select ID, FN, and in brackets, select get xdata dot xdata from xdata from get xdata xfiles.id and closing xdata from xfiles. So that's a very easy way to use that functionality. But currently it's a little bit boring because currently we have the data in our local database, so it's not such a big deal. But if we do the archive operation on that current database and we simply commit that and we simply disconnect and reconnect to that database, and we simply using the same SQL statement again, we see exactly the same data, even that now the data did not come from the local database, it came from the archive database. So now we have exactly the same data. We do no longer have the informations here in our local database, but we have it transparently in our second database. So it allows us really a very simple way to put some data out of the production database into a second database. For example, for archive reasons. And the very funny thing is also what we can do here now in the second database. We can, for example, say the second database is a database which is now here in the DB folder directory. We rename that database to a, for example, archive database. We simply say this one is the archive database 2019, and we open a new database. So let's have the basic idea behind that. We have here the original database. The original database, for example, should now be empty. That's what we simply say here in the X file. It should no longer be there. Empty table. And when we disconnect there, we want to add the clone registration info, and we want to have here the 2019 database. And when we connect to the 2019 database, we will have the same operations again. And when we go now to the get X data functionality, it could be a very easy way to have here multiple connection strings inside a local table. I will make it even easier. I simply do that and copy that to a second statement. So what is the basic idea behind that? I simply start with the current production archive database. The production database is step number one. If it does not contain the blob data, I will get a connection to the first archive database and get the data from there. And if I still have not found that, I go to the last year's database and look up if the data might already be there. So if we do that, and we simply say here exactly the same operation again, we simply have now the same information here, even that we do not have the data in X files, and we also do not have the data in the DB files archive, because in DB files archive, I have to go on the right table, because this one is the one that I wanted to show. This one is also empty. This is completely empty. And the funny thing is, in that moment, when you have created, for example, a production archive database like this one, to be the last year's production database, you can do the following. You can, for example, say here, database properties, it is now a read-only database. When you did that, it is extremely simple, because now nobody can, even if you want, delete data from that database. You cannot do an update, you cannot do a delete, you cannot do anything in that database. It's impossible to work with that database and write operations. And that's one of the reasons why this 2019 database now could be, for example, done in a single time backup restore at the end of the year. And you never have to backup and restore that database anytime again, because it can never change at any time. Even that I now changed it from from read-write to read-only mode, when I go back to my database and I work with my SQL editor and I simply do again the SQL operation, it still works, because it can still operate in that combination of databases transparently. And the cool thing is also for you, when you have when you have to work with real big amount of data, it's also no big problem. We can still, for example, do some more operations. Let's remind you of the following. We go to the import, and we import now a different directory. We import some new files for whatever reasons. Let's import, for example, a GT2 directory, or we also do some additional stuff. We simply put, for example, some files from Firebird. So the full Firebird 3 subdirectory, for example, I want to import for whatever reasons, just to have some data inside our database. Let's have a look what we are doing here. We are simply changing that directory to this directory, and we now import some new data in the database. So now we have here the Firebird message file that cannot be opened. That's no big problem. We do the try accept. And so always when you do not know what to do, ignore it completely. You know that. Most of you will have the same kind of code in your application very often. We started again, and we were simply ignoring the files that are currently locked because of the Firebird operation. We disconnect, we reconnect to the database, and we currently have the X files. All the original files, the metadata of all files are in the current production database. The metadata is not the big stuff inside your database mostly. But when we here go now to the newly imported files, we here now see that a lot of new files are imported, and we can simply do the same functionality that we already had inside our production database, X-Files arc. So any table content that still has the data in X data column is now transmitted from the main production database to the DB files archive database. So let's start this operation. That would be an operation that can be, for example, done every week, every month, every day, or how often you want that. And now we have, again, almost clean X-Files table, because all the content of the X-Files is here completely empty. All X data is completely shifted already to the second database. Because in the second database, we now have here only the information. For example, this one is fiber config file and a database config file, some executables, whatever you want to have there. It can be done exactly in the same way. And we still have the old data in our DB files archive database, and the DB files 2019 database is still read-only, so we can still not delete some data from that, because this is our read-write current production archive. This one is the last year's read-only data archive, previous year, and so on. And we still have the possibility, when we go here to the SQL statement that we have used already several times, this one, that we have here now data from, this part is definitely taken from 2019 database. This part is done from the get files from the archive database. And perhaps is some other files later also in the current production database. So it's completely transparent to you. When we want to have a more nice version of this one here, we can, for example, do the same technology here. We have here the internal function, and we currently have the getXdata database. And when we have, for example, here, we want to have the function, we can, for example, do the fxdata, I call it, returns blob. And it needs some input parameter. We are using exactly the same input parameter, the ID, which is a big int. And what we do now here simply is calling the xdata, we call DCL, xdata blob. And what we do is select get xdata dot xdata from xdata ID into xdata, and wherever it comes from, I want to have it returned by that function. From get xdata. So I have to write it correctly. And the interesting thing is now, when we go back to our SQL statement, that can be now done much nicer. fxdata in such a statement. So now we have the same functionality. We simply go with a function inside our procedure. We can write really nicer SQL statements to have the xdata xfiles.id or something like that. And we can simply get a result set, which is a blob. And we can simply also say where ID equals 1, 2. So what happens now if I get a SQL statement 1, 2? So the equals ID equals 1, 2. In that case, the original operation here is now detecting which one is the one that is required for that. And only after that, all the other content is taken from that function. So it's not done for every possible operation. It is done for the operation that is really needed. As you can see here, we have now a plan that the X files is really used in a RDB$ primary, And when we go into the performance analysis, we directly see here that we have only two index reads. One is the local file on the and one is the function that is taken at the end. So it's also a very flexible and powerful way to work in that way. And the view, when we are working with the view, would have also no problem to do it in the exact same way. We can also do here the fx data ID. And now we have it also as a part of the view. So it's also completely transparent to anything. And it's also extremely flexible to be done to display the data, for example, in a kind of a grid or in kind of a PDF viewer or whatever you need in that constellation. You always have the possibility to improve your storage whenever you need that, because when you have a small customer who has perhaps 100 megabytes of data or something like that, or 1 gigabyte or 10 gigabyte of PDF files inside the database, it's no problem that you leave the data in the production database. When we are talking about databases which are perhaps 1 gigabyte or 2 or 5 gigabytes, do not even think about putting them into multiple databases. Firebird is so fast with this kind of databases, it makes no sense. But if we are already talking about databases in the time frame of approximately 50 or 100 gigabyte, it depends a lot on the speed of your server, if it's really reacting fast or not. And if you have, for example, a customer like we have, where we are talking at the moment about approximately 1 terabyte of PDF data inside that database, just have in mind that you have to do perhaps a backup and restore of your database. Okay, congratulations for the waiting time for 1 terabyte backup and restore. First, you need an additional terabyte for the space for the backup. And if you do not want to overwrite the production database, you need 1 more terabyte for the restore possibilities, to have a restore on a secondary database. And we are in that moment already in the area of approximately 3 terabyte. And that could be a little bit of a problem for example, if you want to work on fast SSDs with that. The really interesting thing is also that this archive database could not only be on a separate drive, because at the moment we are still working here on the drive C. It could also be on a separate server, depending on the size of your customer's data. So let's have a look at this original function again. Every interface to that data is always the getXData functionality. And this one here is no problem to be routed to a remote database, somewhere in the cloud or whatever you will call it, to the customer when it's on a remote machine where only the blob data is stored. It could be a very simple way to make it a little bit easier to have your customer only in the local environment is major production data. And major production data in that case simply means every table for the original database, except the blob data, is in most cases the part that is much more important when you are having a database crash, rather than having the blob data. The blob data is often not so important. For example, if you see the content of a PDF file, or you see a content of a technical drawing or something like that, that's most of the times more or less easy to replace by a content of a former email or something like that. But if you have seen one of my previous videos, I think it was number 2 or 3 of the videos, I showed also to use a database, for example, also to store the emails inside the same system. So it's also no big problem, for example, to store emails, yearly emails inside your system and put it in the same way in archive databases. And you have no problem, for example, to find an email that was sent by one of your employees or your customer's employees, or sent to your customer or to you inside your database, simply by doing a select using your metadata. The metadata of the database still has all the information that are needed, for example, in an email, CC, BCC, and all this information can be really simply extracted from the emails when you're using the functionalities. If you were not there, IBEC underscore EMAP functions we have inside IBExpert to have access to EMAP mailboxes, POP3 access, and when you want to send emails from that, it's also possible to have a send mail with attachments. For example, can automatically create email attachments from your database content. One of the parts that I showed also in a previous session, I think, was here also to work with a report manager to create, for example, a report based on your database content on the fly, which is then, for the scripting perspective, can be used for create report functionality. And the export report, for example, allows you to export the data, for example, to PDF or whatever format you want in that moment, to send it as an attachment by SMTP send mail, more or less automatically. But when you have a lot of data in this kind of different servers, you have a mail server, you have a kind of a document management system server, DMS server, you have some technical drawing server, you have some file system somewhere. If you get really in big trouble with a, for example, Trojan problems or virus inside your company, it could be already a big problem if you are working with a file system that is read-write to any user, because especially when you're doing an encryption Trojan, you have already a problem with all that files. A customer of us reported a few weeks ago, or a few months ago, he's a very good customer for the IBExpert tool. He has approximately 30 employees, and he was reporting from one day to another that he had to replace every 30 licenses of IBExpert by a new installation. And that was extremely funny from us, because we were asking why. And he said, okay, we had a problem with the Trojan, and we were not able to decrypt all the stuff, all the computers that were active over the weekend and on the first day of the week. And they were in really big trouble in that moment, because every file in their file system was completely encrypted already. And whenever you get access, perhaps by error, to any file system on your NAS system, and your Trojan in the background still works, could be already a big problem. The interesting thing is that when you're working with a remote database, so this one here, for example, does not need to be a local share or something like that. It could be a remote database, and you have all the files inside the remote database. The Trojan does not have any chance to get to that file system. It might perhaps get access to the database file itself. But if you have access to the database file itself and your Trojan will work on that database file itself, you might already have a stupid installation of Firebird. We always recommend to use Firebird on Linux systems, because one of the easy things is you do not get any unwanted updates, and Microsoft with Windows even in 2019 is already, I do not want to say my official words about that, but it's already really a problem when you want to have, for example, a production database, and the production database needs to be restarted because Microsoft want to install you a new patch for Internet Explorer or whatever kind of bullshit that you do not even want to use on that server. What is also interesting to know is when you are working on the same instance of Firebird, and especially in Firebird 3, there are not so much advantages when you are working with Firebird 3 on a local Firebird server on multiple instances. With Firebird 2.5 super server, we are sometimes using multiple instances using different affinity settings. So we had, for example, on one port, one Firebird server who's using a specific core, and another Firebird server instance in a separate directory is using a separate Firebird process on a separate port and is using a separate core also. But when you are working on a single instance on a local machine, one of the advantages that you could also have in mind is we do not have to use the TCP IP address in that connection string here. At the moment, we are working in one single Firebird instance because we have only the current installation with the current Firebird server available. And when we are going here now, for example, to the data again, and we say, for example, let's go back to the X files, and we go, for example, now to DB files archive, and for whatever reasons we want to do the de-archive. Now we have de-archivated all the files, and we want to see the data again. And we see the same data again. We also have the possibility to have a look at the view. In the view, we have exactly the same data, even that some of the data come now from a completely different position. The interesting thing that I wanted to show you is really simple. What the getX files function, getX data function, will do when we do not use a TCP IP statement, a TCP IP address, or a server name in front of that. We are using the so-called XNet protocol. XNet protocol simply means we are not using a socket connection, we are using a memory page for the operations. And when you have multiple operations to be done, it's often much faster to do it using the XNet protocol rather than using it in a external functionalities with the compared to the TCP IP version. Just have that always in mind. If you can do that with the XNet connection, do it with the XNet connection. If you cannot do that, you will understand that. You can also change that. It's no problem. It can be done here, for example, using the TCP IP address, and the other one does not use the TCP IP address. Technically, that's also no problem. If you have a extremely high load on your database system, you can also use some kind of random function. Rand is a function built in already in Firebird. And depending on the result of the random function, you can, for example, take the data from server 1 or from server 2 or from server 3 or whatever. So it's also no big problem to have the data already extremely fast sent to multiple servers. And you can, for example, have a multiple Firebird servers can, for example, access the same archive server or multiple archive servers. It's not such a big deal to implement that. The execute statement on external allows you also some other functionality. You also have the possibility with autonomous transaction. That's also possible. We do not want to have that here, especially we do not want to have that in the archive or de-archive functions. We can, for example, say here, execute statement on external with autonomous transaction, but in that case, it could be that we are running here in an error and the update is still done. In that case, you are already a little bit in trouble. What happens, for example, if I do the following? Let's have a look at what we are doing now. Is we are doing the archive operation. We commit that. And we do the disconnect. We do the connect to the second database. And we simply say here, we want to have here, for example, a update somewhere in the blob. For whatever reasons, we are doing an update in the blob. I simply write here a new line. I commit that. And I am doing a write operation inside my archive database. And I just want to show you that when I now do a de-archive functionalities, and I try to do that, I get here also using the execute statement or the delete statement, I get a deadlock. The deadlock is also working with execute statement on external if you're not doing the autonomous transaction. If you're doing the autonomous transaction, you have a problem. In that case, it could be done that one part of the operation is already done. The interesting thing on that is really simple. Because we have at the end the same possibility as we would be work in the same database. So technically no problem to do an execute statement on external. And if you are locking something, you get the same deadlock as you would get when it would be the local database. So always have that in mind. Let me show you some of the basics that we want to have also with the execute statement and the interdatabase connection in a separate operation. So let's go back to the database. If you have some questions, for example, just write them down in the chat in GoToMeeting chat. And I can perhaps have a look always at some questions when you want to get with me in some more details or so. It's always possible. I try to answer some of the questions at least. And if you are already completely out of free space in your mind, and you, for example, get into the questions tomorrow, also no problem. Just try to send these emails to support@IBExpert.com. Just write down that you have some more detailed questions regarding the video sessions. And we try to answer all these questions. If it's not one of the questions that takes, for example, 100 lines and 100 several, as Kevin said, a lot of things to absorb. The good thing is when you are watching the video later, you can use the pause button, the break button. You can rewind me. It is much easier rather than to do it in real life. What I wanted to show you is a typical situation. Let's have a look at the database DB1. I will do the delete all on DB1 database, and I will commit that, and I will disconnect, and I will do the same on DB2, delete all. So we have two empty databases, and now we want to have some resulting data in our database one, and I will show you a little bit of way how to process interdatabase communication if you want to copy data from one database to another more powerful, like you have perhaps the basic idea had before. So let's start with that database. In that database, you have, for example, at the moment also the possibility to run here. For example, I think we will do a 200,000. We will create a lot of demo data, but we want to have some reaction time later when we want to send some data from one database to another, to be able to simply see how powerful it could be when you're working on such a database to transmit data with more or less the same technology. Because in some situations you not only have to have the problem, you do not have to solve the problem that you are working on a local database and move the data to another database. Sometimes you just have to synchronize the database or several databases between each other, and this could be a much more complicated solution that you need in that moment. I hope I did not have too much time. That's 1 minute. That's perfectly fine. And now we have in DB1 a lot of data. In DB1, we have, for example, a product table. And the product table, for example, is a random table with a lot of title names and with an actor names. Sometimes really interesting what kind of random names. Cane driving lady, rage Saturday league, could be sometimes really interesting for have a script editor to write a script for a movie for that. We have a table which is called TMP title word, and these are title words from movies, and they are simply connected together as 3 words by random, and you have a really interesting title sometimes. Gladiator, Valentine, Darko, whatever it means. So the editor can, for example, now think about what does it mean. Let me show you how to transmit the data from one database to another. Different ways. The simple way. The simple way is, for example, exactly this one. We are on db1.ftb and we want to put the data in db2.ftb. We take the connection string and do the following. We simply write in the SQL editor, insert into brackets product, select from product. So what does it mean? IBExpert allows you, if you want to do that, to do an insert into new table anytime. If you want to have the data inside your local table, I will first start with that. You can do it also _BAK, like backup. We want to have all the product table into a local backup table. When you press now F9 in IBExpert, IBExpert tells you, okay, table doesn't exist. Should I create it? Yes. 200,000 records were copied inside our local database from one table to another. It's extremely fast, because in that moment when we are doing that, we are simply doing the SQL statement that is exactly doing the same operation. But the only thing is that we are detecting here the error, and if the error from Firebird comes, oh, we do not know the table, which is here the target table. In that case, IBExpert detects itself that the table could be an option that we want to have that to be created automatically. When we are using that in front, we are not working on the current database, we are working on the second database. Let's do it. It is disconnected. here is really the connection string or the alias name like it is written here inside IBExpert. That's important. So everything that you are reading here should be taken here. So the alias name is important. This one is the alias dot table name. And we want to have it not in the product bug, in the second table. We want to have that in the same name table that we are already working on. We are starting that again. Is it disconnected? Want to connect? Yes, I want. And now you can see here, for example, a database to database transfer. You see here 30,000, 40,000, 50,000. It could be considered to be fast, depending on your idea of what is fast and what is perhaps more or less fast. I can guarantee you that a lot of people writing their own code often believe that their application should do such a job much faster than it does it in reality. If you are doing, for example, a Delphi application and you are opening a local database, local data source, and you are doing insert into a second database and so on, it could be really take a lot of time. I do not know if we have here the real time. We do not have the real time. We just have here the 390 milliseconds for the prepare operation and the create table operation. But what I wanted to show you is now really simple. We have approximately perhaps 30, 35 seconds, 40 seconds, something like that. That was exactly this operation. Let's delete all the data. Table, empty table, do it again. And when we did that, we do a different way to transmit the data from database 1 to database 2. So this one is really on the fly, always available. You just have to write it in IBExpert, and IBExpert detects everything else. It will create a table if the table is not already available. If the table is available, it will try to do that with the existing table. But what we want to do next is extremely easy. Execute block as begin end. So let's think about the following way. We want to transmit the data from the local product table, 6 columns, to the remote product table. Let's do it in that way. Drag and drop and declare variable, type of column, and so on. So we do not have to think about which are the individual columns that we are working on. And we see here now, for example, a lot of variables. So what do we want? We are working in the context of DB1, and we want to have every record that is in the product table in DB1 used by a for select statement. So drag and drop in the for select statement. Here we have all the same named columns. If we want to have a prefix for the variable names, just write here var prefix, and we have an X in front of that or whatever we need. That's also a very easy way to do so. You can also do for example, a alias name automatically to make some of the operations a little bit more easier. Alias P, for example, in that case, or when you are working on a single table, it's not needed. So we say apply. For select from into do begin end. What do we want with that data? Execute statement. Exactly the same that we did a few minutes ago. Drag and drop, insert into, same operation as we know already. And we want to have in the second bracket the connection between the internal parameters and the external parameters, so the named parameters list, ID equals ID, category ID, and so on. And then we have here the second operation, and to see everything on the screen. On external, and as we know that already, we want to have the connection to DB2. As user is DBA. And I think in this database, I do not have the PVD functions. So I have to write it here in code. As user password master key. So we do not want to delete anything. We just want to copy the data on the second database. So let's try to start that. And find out how long does it take to transmit 200,000 records. And this depends a lot on the real connection. 200,000 records are now transmitted within 16 seconds. So that's already a really good time, I would say, because we are working here with the same basic technology. I will do a rollback for that. And what does it mean to do a rollback? The rollback now also means that all the inserts here are also rolled back. So your transaction with an execute statement on external is exactly in the same technology. And to show you the difference between the socket connection and the non-socket connection, if you are working with the same database on the same instance, and not on a different instance of Firebird, simply remove that here, and we try it again. So 9 seconds. Could be perhaps the first time that you really found out that you have interesting results or positive results by using a so-called XNet connections. When we are going to the database monitoring of DB2 and we go to the attachments, and we see here, for example, the different connections. And we make it a little bit wider here. And we see here, for example, we see no remote process. And we see, I will just deactivate the auto refresh. And we see here, for example, the 200,000 operations and so on. This one here, for example, does not show us any remote protocol at that moment. If you have no TCP/IP version 4, you will definitely have the XNet protocol or the server process to server process protocol. And that's sometimes really interesting to work with that. And as you have seen now, we are in the area of approximately 20,000 records transmitted using a virtual machine. That's really important on that machine. You are working with a virtual machine here, and the virtual machine is definitely much slower than a physical machine. In reality, when we are doing that on a production server of the so-called IFS server that we have in high performance environments to be used, we are not talking about 9 seconds, we are talking about 2 or 1.5 seconds. So for example, we are in the area of a database to database operation of, without any problem, 50,000 to up to 100 or even 200,000 operations per second using that technology. And whatever you try to do with a client to database server to second database server connection, you will not even get in the area of that amount of data per second. The only thing that you have to do, for example, is nothing else than putting this source code into a tQuery in the SQL. You can create it by runtime or whatever you want. And you simply have to say execute exec SQL depending on your query component. And it will do exactly the same technology. And it will be much easier for you to do some kind of database to database operations much faster than you might have done that in the past. So I think that could be also a very interesting way to do so. Some basic ideas, if you want to have a kind of a data pump, we are currently working on the basic idea behind that, that we are doing what we are doing now, tools, table data comparer. Let's do it in that way. So you do not have to write every piece of code yourself, but technically it's sometimes interesting to be able to have for high performance stuff this kind of possibilities when we are doing the empty table again. And we want to have the operation done more or less in a way to be automated. We can say tools, table data comparer, and we say here simply drag and drop. This one is our master database. This one is our target database. And this one here now has some different tables. Here, for example, 2 tables that are in the master database, but not in the target database, but that's no problem. We just want to transmit the product table, if nothing else. And what we also want to do is we want to have the online synchronization to be done. Why should we do that? Online synchronization means simply it will start automatically. If it detects already one different record that you can detect here in the options, we want to process inserts, we want to process updates, we want to process updates only for the columns that really needed to be updated, and we want to process deletes. We want to have milliseconds in the timestamp values if needed. Alter sequence is not needed in our situation. We want to use update or insert instead of update insert statements, but we do not want to have that. If we would work with hashes, blobs, we can use the hash function for that. We can also do the put, insert, update, and delete statements into blocks. We can have a look at that also. What happens when we do that in the second step. And we can, for example, say commit each Firebird block. We can say commit work maximum after 2000 records. And we want to put the hex values, the block values into hex strings. We do not want that. And we can, for example, say if you're working with that functionality and it will run on a very big amount of data, could be a problem that you run out of memory. You can say here, for example, something like 20,000 or so. In that case, it will process up to 20,000 statements in memory at the same time. And after that, it will, simply stop to synchronize that, what you have selected here, the online synchronization. It will stop until the next 20,000 are available. So what we did now is also the possibility to ignore synchronization errors. If we, for example, do a update statement on a locked table on a second database, it could run in in an exception, in a deadlock, and that would be no good idea at that moment. We can simply say, okay, if there is an error, who cares? We are not interested in that. When we execute that, it will run automatically, but we will later also have the possibility to run that in the IBE block, and I will store the IBE block here into a CMP operation. And that is, for example, to be executed now. And you see here on the right upper side, the executed operations. So the this functionality to do so is also really fast, but it's not as fast as an execute block database to database functionality from inside Firebird to Firebird. But it's still a very good way, for example, to have the big advantage if you, for example, need to detect if the record is already there. In that case, you want to do an update. If it's not there, you want to do an insert. If it should be deleted, can be deleted, etc., etc. So, and what we have done here now is really simple. We see here 40 seconds was the execution time. So that is extremely easy to understand. We do not want to have the result in script editor. It showed us we have 200,000 operations to be done, 200,000 inserts. Let's try that again. Now the 200,000 records are already there. It took about 3 seconds to understand that there was no change needed. So no operation was needed. It's extremely fast when both tables have already the data. When I go to the product table and change some data manually, and I simply commit that, and I want to have, that was DB2, so the target database. And when I go back to DB1, you can always have a look here where the DB1, DB2 setting was, left master database, right target database. And if we run that again, it will now detect that 11 updates were needed. And it took around 3.4 seconds to compare 200,000 records on both database tables to get the result set. And if you do not want to execute that automatically, you can also create a statement SQL script here. That's also possible. And if we are going, for example, again to the product table and empty the table, back again, this one is the one let's be sure that we are not in the wrong database. One of the things, wrong database, perhaps some of you saw that already in a older video, color mark, the possibility in IBExpert to have, for example, a colored bar on top of the editors here. For example, this one is a DB2, this one is now always red, and the other one is has no sign on top of that. So let's have a look here and go back to the empty table. And empty table, commit that. And let's go back to the data comparer function. And now the data comparer, we will change a little bit the data comparer, that we want to put the insert, update, delete statements into blocks. So we will see at that a little bit later. And we want to not to commit each block, we want to just have that running as it is. So let's start that. Synchronization still in process. And you see here on top how many blocks were already executed and how many are still to be executed. And you see here, it took, without the blocks, it took around 40 seconds. With blocks, it took around 20 seconds. So it's almost twice as fast. And when we have a look at that result file, we can have a look here. It's a very big result file, so it could be a problem that when we want to load it in IBExpert, it could be a problem, but it still works. And that's a construction, the basic construction to make mass operations much faster. Simply write an execute block before the operation, write all your inserts with individual values into separate lines, each with a semicolon at the end. And at the end of the block, you have to write an end and a semicolon at the end, and then you start again the next execute block, etc. It's also a good possibility when you're working from a client application where you want to do mass importing of data, mass creating of data. It's also the same way to improve the speed of your applications in the same way. It's also very helpful. What IBExpert does is it detects some limits. It simply, for example, says when you're doing an execute block, you do not have to, you're not able to run unlimited statements inside an execute block. The basic limit is, for example, for insert statements, you have, I think, 250 whatever statements in one block. For update statements, you have 126 or 27 statements available. And for update or insert statements, you have approximately 82 or so statements in one block. And one block should not be bigger than 32K of source code. So that's one of the reasons why you have to not use one big block for everything. You have to use different blocks, but most of the components that you are working with from the Delphi or .NET market or whatever you are programming on simply give you the possibility to replace any SQL statement that you are working with an execute block and several statements inside. And that allows you to improve the speed of your application also extremely. And as I said already, it's also possible to do the execute block directly from your execute statement on external operations also. That could also be done. So also when you do an execute statement on external, that execute statement on external can also be an execute block. It sounds perhaps a little bit strange, but it's really a very powerful way. Yeah, I think I showed you most of the topics that I wanted to show you. When we, for example, want to have the database completely compared, or we simply want to have the comparison done by SQL statements, GT2, IBEscript, cmp.sql. We can also do it from here from command line. And from command line, we are also almost in the same speed. Let's go back and drop all data from the DB2 table, empty table. And if the same execution is done, it will take some more time because at the moment we are now still doing a lot more executions on the second database. So it's why the steps are a little bit smaller. But you will at the end see that the full operation is also done in that way. Yeah, I think I was able to give you some more functionalities in your knowledge that you can use in your own operations and your own daily programming. There's so much possibilities that you can do inside a Firebird database without the need to have that done outside a Firebird database. And I always recommend to have that always in mind. And we try to have all the functionalities that could be possible also in IBExpert. And yeah, I think it's a very good way to do it and to communicate that in this way. For the next session, I think we have to wait almost up to 3 weeks because we have now 2 weeks of customer appointments where I'm in the evening, always in business. And so perhaps in approximately 3 weeks, we will definitely have a new video and a new session. So we just have a look at at our website. If you need some more information or whatever you need, just contact sales@IBExpert.biz, or for USA and South America, contact at IBExpert.com. And I would say enjoy the rest of the day. And now it's time for a beer. And we will meet again in approximately 3 weeks. Bye-bye.